Welcome and hello. This is a video tutorial on HEC ResSim, and in this video I want to talk about the reservoir editor and specifically adding and removing elements from the dam. The dam has a lot of elements, and I'm specifically going to talk about leakage, tailwater elevation, and forebay head loss. There are a lot of other elements to add, which I'll also mention, but I'm not going to go into detail about certain elements like diverted outlets, controlled outlets, uncontrolled outlets, power plants, and pumps. Those will be in later videos. What I have on the screen here is a very simple reservoir network that's been saved. There's a couple reaches, junctions, and one reservoir right here, which we'll use to edit. To make to edit that reservoir, go ahead and click your pointer tool or your reservoir tool and then right click, edit reservoir properties, and we get this dialog box, which we've seen before. At the top is the reservoir name, and then on the left is our reservoir tree, which shows the pool and the dam. We can actually click on the dam, and at the top, it's the fully qualified element name for the dam. And this is just the default name because this is the name of the reservoir and the name of the stream. But if we only have one dam, it may be simple to just right click, rename the dam and call it dam. And then we see it's updated here in the tree and it's updated over here. I think I can just click the reservoir again. Yeah. So it just says reservoir one dash dam. Even if you don't have any outlet structures in the dam itself, the dam will serve as an uncontrolled outlet structure for overtopping, like a weir. So the values to define that overtopping include the elevation and the length. So I'm just going to type in a few numbers here and good, apply. All right, to go ahead and add elements to the dam, we can click up on dam here and add elements, or we can just right click on the dam itself as it's listed in the reservoir tree, and that's my preference. Different elements we can add include controlled outlets, uncontrolled outlets, power plants, pumps, outlet groups, diverted outlets, leakage, tailwater elevation, and forebay head loss. I'm going to go ahead and just add a few controlled outlets. So there's my controlled outlet. As you can see, it got added to the tree, and there's data to input for that particular controlled outlet. You can add multiple controlled outlets. There's another one. There's a third controlled outlet. The default name may not be very helpful, so you can rename these controlled outlets. And ResSim allows you to rename any element that you're allowed to create multiple versions of. So I could just call this gate 1, and I'll call the second one gate 2. I'll call the third one gate 3. And that may have more meaning to that particular dam. All right, so in the case of leakage, for instance, and evaporation or seepage, we can't rename that because there's only one leakage through a dam. We can also delete by right click and delete. So if I want to delete gate 3, there it goes. Okay, let's talk about leakage. Leakage is simply the water loss through the dam. So remember with pool, we can have losses through evaporation and losses through seepage. Well, with the dam, we can have losses through leakage. So if I add leakage, it shows up leakage. And if I right click, I can only remove it. I can't rename it because there's only one leakage. But I can define the leakage in CFS as a function of the water surface elevation behind the dam. So I'm just going to make up some numbers here. You can see the rating curve is defined over on the right, and I can just click apply. Outlet groups are the next element I want to discuss, and outlet groups are right here. Okay, so I added an outlet group. I can also rename the group. We call it group 1. How about group A? All right, and then within an outlet group, I have a new menu up here. I can add elements to that group, or right click on the group and add elements this way. So I can add some more controlled outlets. We can call this, let's call this main gate. And then let's add another outlet group, or sorry, controlled outlet. We'll call this lower gate. Outlets that are grouped together and are treated as a single unit. And this allows you to apply rules to the outlet group instead of to each individual outlet in the group. The next element I want to discuss is tailwater elevation. Right clicking on dam and then add tailwater elevation brings up the tailwater here. We have options to define the tailwater as a constant value uh, and or based on the downstream control element or based on a rating curve. Now the rating curve can be a simple rating curve, which is probably a little more common, or it can be based on function of a value, which you can define and based on a model variable, external variable, state variable, or two variables. So that's a little bit beyond what I want to talk about in this video, but we'll see examples of how that works in a later lesson. If it's a simple rating curve, then you can type the data in or you can just paste it in. So I did copied some data from Excel and I'm pasting it in with Control V and click Apply. Unlike a radio button, these checkboxes allow you to check all three. And what will govern is the highest elevation of all three. So ResSim will run the calculations and identify the highest elevation between those. Tailwater conditions governs all of the elements within the dam unless tailwater conditions are defined specifically for one element. So for instance, if I went ahead and added a power plant and I added a pump, and then for the pump, I added tailwater elevation, and it may be a little bit different than the main tailwater elevation, then all of the elements, so the pump would go ahead and actually use the tailwater elevation that's defined just for the pump. It sort of overwrote the tailwater conditions, and any element that doesn't have its own specific tailwater conditions defined will just use the main tailwater conditions up here uh, defined under the dam element, if that makes sense. The last element I want to talk about is the Forebay head loss, and this refers to the amount of hydraulic energy or head that's lost from the water at the water surface elevation behind the dam before it hits the turbines in the power plant. So, there's major losses and minor losses through pipes and penstocks and contractions and so on. And the higher the flow, the higher the head loss. So go ahead and type that data in this table and save it, or you can paste it in as well. That's all I wanted to talk about in this video. We covered adding elements to the dam, deleting them, renaming them, outlet groups, and specifically talked about leakage, tailwater, and the Forebay head loss.